What are the different data types that Elasticsearch handles? From text to numbers, dates, and more, Elasticsearch stores and queries diverse data types with precision. Imagine a library where each book is labeled and organized not just by title but also by genre, author, and publication date. This meticulous categorization allows for lightning-fast searches and retrievals. In Elasticsearch, data types act as these labels, guiding the system to swiftly navigate through vast amounts of information. Just as a librarian efficiently locates a specific book amidst shelves of varied genres, Elasticsearch effortlessly locates data points within its indexes. So, how does Elasticsearch manage this data diversity so effectively? Let's delve into the intricate world of Elasticsearch's data types and uncover the mechanisms that power its seamless operations. Why do data types matter in Elasticsearch? This powerful search engine relies on efficient indexing and querying to deliver fast, accurate results. Each field's data type plays a critical role in how data is analyzed, stored, and searched within Elasticsearch's inverted index structure. Choosing the right type is key to avoiding slow queries, inaccurate results, and wasted storage space. Throughout this presentation, we will delve into the core data types in Elasticsearch, offering practical mapping examples and insights into optimizing your application's performance. From primitive to complex types, text versus keyword distinctions, numeric selections, date formatting strategies, and array handling mechanisms, we'll equip you with essential knowledge to enhance your Elasticsearch experience. What are the key categories of data types in Elasticsearch? In Chapter 1, we delve into the essential classifications. Primitive types encompass fundamental elements like text, numbers, booleans, and dates. Complex types handle structured data such as objects and nested documents. Additionally, specialized types cater to unique formats like geopoints and IP addresses. By understanding these distinctions, you can craft schemas that optimize query performance and storage utilization. Choose the right type for your data needs and unleash the power of Elasticsearch's versatile categorization. In Elasticsearch, a mapping acts as a blueprint for how documents and fields are stored and indexed, akin to a database schema. Each field's data type dictates its behavior during indexing and searching. While mappings can be inferred dynamically, explicitly defining them offers precise data control. Best practices include defining mappings explicitly in production, selecting types based on query patterns, and considering storage and memory implications. The basic mapping structure involves assigning appropriate data types to each field, as shown in this example index. By specifying mappings, Elasticsearch is directed on how to handle each field effectively. In the world of Elasticsearch, mappings play a crucial role in shaping how data is stored and indexed, much like a database schema defines the structure of a database. Each field in a document comes with a data type that influences its behavior when indexed and searched. While dynamic mapping can be handy at the outset, explicit mappings provide granular control over data handling. When working with mappings, it's essential to define them explicitly in a production environment, choose types based on query patterns, and take into account storage and memory implications. The basic mapping structure involves assigning suitable data types to fields, as illustrated in this example index. By detailing mappings, Elasticsearch is guided on precisely how to process each field. In the realm of full-text search power, text fields play a pivotal role. As text is indexed, it undergoes meticulous analysis, broken down into terms, stripped of punctuation, and even subject to lowercase conversion, stemming, or stop word removal. This process not only enhances search flexibility by enabling fuzzy matching, synonym expansion, and relevance scoring, but also demands more disk space and memory due to maintaining inverted indices for all analyzed terms. When the priority is search quality over storage efficiency, text fields emerge as the optimal choice. So, in the landscape of data storage trade-offs, text fields stand out as the heavyweight champions of search prowess. In the world of keyword fields, precision reigns supreme. Unlike text fields, keywords store data without analysis, making them ideal for exact matching needs. Think email addresses, product IDs, or status codes, where specificity is key. So, when you seek to filter, sort, or aggregate with pinpoint accuracy, turn to keyword fields. Need to sort alphabetically, or filter by specific values? Keywords have your back. And don't forget, using multi-fields allows for indexing content for both full-text search and precise matching. Mastering keyword fields opens doors to efficient term-level queries and structured filtering. So, embrace the power of exact matching and elevate your data handling game. Ever wondered how a simple phrase like "quick brown fox" is handled by search systems? In a text field, it's broken down into separate words, allowing for flexible matches like "quick fox" or "brown." However, in a keyword field, only the exact string "quick brown fox" is recognized. This contrast highlights the trade-off between flexibility and precision in search functionality. To optimize results, many systems combine both text and keyword fields within the same schema. By leveraging the strengths of each approach, users can enjoy both comprehensive search capabilities and accurate matching. In the realm of search optimization, it's all about finding the perfect balance between flexibility and precision. Are you ready to dive into the world of numeric data types in Elasticsearch? Let's explore how choosing the right size can optimize storage efficiency and performance. From integers to floating point and specialized types like half_float and scaled_float, each option offers a unique balance of range and precision. Remember, selecting the smallest type that fits your data range can make a significant impact, saving memory and costs at scale. So, which numeric type will best suit your needs? Consider the possibilities wisely. Ever wonder how to select the right numeric type for your data needs? Consider the practicality in various scenarios. For user ages, opt for a byte with a range of 0 to 120, saving memory in vast databases. When dealing with product prices, a scaled float, like £19.99, prevents floating point errors in financial calculations. View counts, ranging from millions to billions, can use integers for most content. For scientific measurements demanding high precision, choose a double type essential for accurate calculations. Each data type serves a distinct purpose, ensuring efficiency and accuracy in your systems. Ever wonder how Elasticsearch handles dates? In Chapter 4, we delve into the date data type, where time-based indexing shines. Dates are stored as milliseconds since 1970, allowing efficient queries and aggregations. Crucial for time series data, log analysis, and sorting, date fields support various input formats. From ISO 8601 to custom layouts like DD/MM/YYYYHH/MMSS, Elasticsearch effortlessly handles time zone conversions and complex date calculations in queries. By accepting multiple patterns for dates within documents, Elasticsearch truly flexes its versatility. Time to unlock the power of time-based indexing in Elasticsearch. Welcome to the world of handling date formats and ranges in your data operations. Dates can be input in various formats like ISO strings, epoch times, or even custom patterns. Internally, they are converted to epoch milliseconds for efficient storage and querying. You can seamlessly filter, perform date math, and aggregate data based on date ranges. When it comes to output, results can be returned in the specified format or as ISO 8601 for consistency. For instance, in a query, you could specify a date range like from January 1, 2024, to February 1, 2024. Date math further enhances flexibility, allowing dynamic queries without the need for hard-coding specific dates. So, whether it's yesterday, the start of a month, or projecting a date a year ahead, date math empowers your queries with agility. Remember, mastering date handling opens new dimensions in data management and analysis. Welcome to Chapter 5, where we dive into the Boolean data type, the backbone of true or false logic. Simple yet potent, it handles true or false values crucial for flags and status indicators. Booleans are key for efficient filtering, prevalent in permissions and status tracking. True values include true, while false values range from false to an empty string. Filtering with Booleans is lightning fast and cacheable, perfect for common scenarios like an RGT request for users. Booleans pack a punch, making them ideal for swift and effective data filtering. Dive into the heart of Chapter 6, the object data type, where nested structures reign supreme. With Elasticsearch, objects store JSON documents rich in nested fields, shaping a dynamic hierarchy. User and address fields stand tall, each with its distinct data type, fostering a seamless domain model. Picture this: John Smith's details snugly nested within user alongside the intricate threads of his London abode and address. These objects, though complex, are internally flattened, ensuring clarity as user.name rises to the index's forefront. In Elasticsearch, complexity meets clarity, crafting a structured tapestry of data. Ever faced the object flattening challenge in Elasticsearch? While objects are handy, Elasticsearch flattens them internally, potentially causing issues with arrays of objects. Consider this: users, name, Alice, age, 25, name, Bob, age, 30. Internally, it becomes users.name, Alice, Bob, and users.age, 25, 30, losing the relationship between Alice and 25 and Bob and 30. Imagine querying for users.name, Alice, users.age, 30. It incorrectly matches due to separate array elements. The solution? Embrace the nested data type to maintain these crucial relationships within arrays of objects. Stay tuned to explore this further. Remember, preserve array relationships with nested data types for accurate queries. How do we maintain relationships within complex data structures? The nested data type comes to the rescue, storing array elements as discrete hidden documents. By retaining the connections between fields in each element, accurate queries on intricate structures become possible. Consider the nested mapping. Within the user's property, each person's name and age are defined. When querying nested data, precision is key. Take, for example, a search for Alice aged 30, which logically yields no results as she is only 25. Remember, while nested documents offer relationship preservation, they come with performance overhead. Reserve them for scenarios demanding intricate array relationships. For straightforward arrays, stick to regular fields for optimal efficiency. Ever wondered how Elasticsearch handles arrays? Well, there's no need for a special definition. In Elasticsearch, any field can hold multiple values by using a simple JSON array. Each element in the array is indexed individually, whether it's a string like Elasticsearch, search, database, or numeric like 85, 92, 78, 95. But be cautious: mixing types like 10, text, true, will lead to errors. All elements must match the field's type. Mapping these arrays is a breeze. Elasticsearch automatically adapts based on the content, whether it's single values or arrays. So, with Elasticsearch, handling arrays is as seamless as it gets, no fuss needed. Ever wondered how arrays really work under the hood in Elasticsearch? When you index a document with an array field, each element is processed individually, following the same rules. There's no special array structure internally, it's simply multiple values for the same field. During a search, a match against any array element will bring back the document, without needing to recognize it as an array. For instance, searching for tutorial in an array of tags like tutorial, beginner, Elasticsearch will retrieve the document. Remember, array order isn't preserved. Elasticsearch views arrays as unordered sets. Arrays in Elasticsearch work as separate entities within a document, adding flexibility to your search queries. In this complete mapping example, we see how various data types come together harmoniously in a product catalog schema. From text to keywords, scaled floats to integers, and booleans to dates, each type serves a unique purpose within a single index. Imagine the efficiency of storing product details with precision: names, descriptions, SKUs, prices, quantities, stock statuses, categories, tags, ratings, creation and update timestamps, manufacturer info, and even nested reviews with authors, ratings, comments, and dates. This robust structure optimizes data organization for seamless retrieval and analysis, ensuring a comprehensive overview of product information. As you design your own mappings, remember the power of diverse data types working in unison to create a rich and dynamic indexing system. When designing your schema, start by analyzing query patterns. Tailor your mappings based on search requirements, emphasizing full-text search, exact matching, sorting, and aggregations. Opt for the smallest data type possible to optimize memory usage. Multi-fields offer versatility by enabling both full-text search and exact matching on key fields. Avoid nested documents unless essential for preserving relationships, as they can complicate queries and increase memory usage. Prioritize explicit mappings over dynamic ones for production indices to prevent conflicts and ensure consistent query behavior. Standardize date formats early on to prevent parsing errors and maintain data consistency. Remember, efficient schema design is key to enhancing performance and reducing costs. In Elasticsearch, mastering data types is key. Your choices impact performance, storage, and query accuracy. Decide between text and keyword for full-text search or exact matching. Opt for the smallest numeric type fitting your data range. Arrays are easy, any field can hold multiple values without special syntax. Preserve object relationships with nested arrays. Understand these core types to design schemas efficiently. Experiment, refine, and optimize based on performance metrics. Happy indexing!